Sophia, nice for you to join us, my friends.
Good morning.
Good morning.
Okay, question here is very quickly. Where did that come from? That came from, let's say I wanted to make this from malonic ester. Okay, where did that come from? Here is the carbon that is next to malonic ester, yes or no? Of course, this has the ester was converted to a carboxylic acid, so this would look like this. Yes, carbonyl. This is that ester. Yes or no? Yes or no? That's how that would look. It was decarboxylated, so we lost this one, and we have attachments here and here. Two attachments. One attachment is going to be that, and the other attachment is going to be this. Yes or no? So you rewrite this benzene ring with CH2, right? And here is the bond to the alpha carbon. So I am going to put a halogen there. So I cut this one. This is alpha, beta. I cut it, and I cut this one here. What do I get from the other one? I redraw the thing, guys. You redraw this, and instead of putting this carbon here, you put a bromine here. Instead of putting this carbon here, you put a bromine there to that. Yes? So carbon, instead of this carbon, I put a bromine. Now I rewrite the other stuff. And I put a bromine there. You agree? Is CH2, CH2, bromine. CH2, CH2, bromine. Yes or no? Did I do those before?
Nope.
No? Okay. We have an exam next week. Okay? Next week. Thursday of next week. And we have another exam the week after that. Next week is what week, guys?
The 21st.
And then the week before finals, yes? So next week you have a test, and I got to do everything before that. My means chapter, and NMR, IR. And wait, maybe we come on Tuesday of that finals exam week, and we have a little bit more class, and then test on Thursday. Okay, where did this come from? I want to make this from malonic esters. Am I funny looking? A little bit? So, how do we make this from malonic ester? You don't know?
No.
Me neither. But I'm not taking the test, okay? Where am I going to cut it? I am going to cut it between alpha and beta. Here's alpha, yes?
Yeah.
And I'm going to cut it there. I am going to cut it right here. And what I get is CH2. You see it? You go down. Br. And then, where did that come from? That came from malonic ester, which is this stuff. How did I go from both of these to that? First thing you do is, you add a base, and this base, it will create the nucleophile here.
Right.
Then you add this halide, and it will attack it here, and it will place it here. And then you can do decarboxylation with what? H3O plus will make this a carboxylic acid, and then you heat it, and what would it do? CO2. Okay? Okay, where did that come from? Very quickly. Now, if you have a lab, no, it's okay, leave it. If you have a lab that you have a test on NMR and IR, you come see me after class, and I will help you with it, okay? I will teach it to you in another class, so you can tell everybody that I taught it to you aside from what they were supposed to teach. Or you can stab them in the back, one of the two. So where did this come from? I want malonic ester, yes? Malonic ester. This is a carboxylic acid. It came from malonic acid. What do you get? Where do I cut it?
Between the alpha and the beta?
Yes?
Yep.
Here's alpha, there is beta. I will cut it here. There is another alpha beta, is it not?
Yes.
And I will cut that one here too. And what am I going to get? Look. That. Do I put the BR here?
No.
No, I do not put the BR there. The BR does not go there. Because there is a carbon before the BR. The BR will go at the end of this. There you go. What's the other one going to be?
3
CH3, CH2, CH3, CH2,
Another.
CH3, CH2, and then the BR across this wiggly line. 2 carbons. Yes or no? And this came from this. How did we do it? In the first step,
We deprotonated.
I deprotonated this,
Yeah.
I had a base,
Become a
react with this.
nucleophile.
In the second step, I deprotonate again, and add that. And in the third step, decarboxylation. Yes, decarboxylation. No, first you got to convert it to a carboxylic acid. But the step is the same. Yes, H3O plus
With heat.
and, or sometimes you can do acidic or basic. Yes, but we did H3O plus and heat or no?
Is this the one where you have leftover CO2?
Yes. That's decarboxylation. That's what it means. Acetoacetic ester synthesis. I am not sure. What is the product of acetoacetic ester synthesis? This is called acetoacetic ester synthesis, yes? What is the product of it?
Don't you get just the ketone and that's it?
Did we do this one?
No. But it's supposed to.
We did something
Okay.
similar.
You did that.
We did something similar to that.
Okay, do it. We did one.
You have to add everything on it first. So you see.
Now, I am not going to do many of these problems because I believe that you guys have acquired a level of understanding in my class that I don't have to do this all the time. If you have not acquired that level of understanding, that's unfortunate for you. Right? Life is like that. Sometimes you are going to die. There it is. It's in between these 2 carbonyls, yes? Very acidic. You are going to pull a proton from here, and what are you going to do with this? You're going
Add
to
it.
place it on that
Place
position.
it, yeah.
So, that's what's going to happen. First, I am going to place whatever this is on this position. That's a methyl group. There it is. And then in the next step, I am going to do it again for the other proton I have, and I am going to add CH2, CH2, CH3. How does that look like? CH2, CH2, CH3. Yes or no? That's how that looks like. And then I am going to add this and heat. What is that going to do? Decarboxylation. Now, where am I going to do decarboxylation from? I can only do decarboxylation from this side, yes? First, that will be converted into a carboxylic acid, and then decarboxylation. And what that is going to do is what? I'm going to redraw it, okay? Relax for a minute. That's what it is, yes? Yes? Before decarboxylation. And then when I do decarboxylation, what happens? Now let's first do this. Let's say decarboxylation, H plus, carboxylic acid, and then you lose this as CO2, yes? So when you lose it, that's when you get it. It's gone. Yes or no? So the product of decarboxylation from malonic ester is a carboxylic acid, and the product from acetoacetic ester synthesis is a ketone. Malonic ester, it is carboxylic acid. The product of acetoacetic ester is
It's a ketone.
a ketone. Michael, you guys want to do Michael? Michael. You guys have weird pronunciations for these things. The name of the reaction is called Michael addition. Okay, and the aldol was either aldol reaction in which you have an alcohol, or aldol condensation in which you have what? What do you get from an aldol condensation? Alpha beta unsaturated. That's what we are going to use here. An alpha beta unsaturated. Alpha beta unsaturated carbonyl. Okay? Now, if I have a nucleophile, the nucleophile can then attack what side? Nucleophile can attack here, yes? And if we do, what delta this, is this oxygen?
Negative.
Negative. That makes this what?
Delta positive.
And can this be delta negative or delta positive? A positive will not be next to a positive, yes? So they kind of switch. So if that's delta positive, this is delta negative, which is, this is
Delta positive.
delta positive. So the nucleophile can either attack here or it can attack here. Can the nucleophile ever attack here? No, never. It can either attack here or it can attack there. Yes or no?
Okay.
The nucleophiles for this Michael addition, where are they going to attack? In the what carbon? In the alpha, in the beta, or in the gamma, or in the omega?
Beta.
In the beta. So this is going to be a beta attack is what we are going to do here. You ready?
Yep.
The attack will be made by what? By a nucleophile. So even if you have never seen this reaction, you know that the attack here will be made by a nucleophile, yes? And you know which ones are nucleophiles because I spent 2 semesters explaining it to you. Where's Pitbull at?
Making a video.
Huh?
New single coming out.
If they were Pitbull, he already would have said, "Oh, professor, I didn't take the organic form with you." So, what is that? What's that called? Is that an dialkyl cuprate? Hello? It's not, right? Doesn't have copper in it. Doesn't have 2 on it. What's that called?
Grignard. Grignard.
Okay. And we are going to do Grignard and then H3O+. And what that is going to give us is what the difference is. Tell me what the difference between that and this is.
One is placed directly on carbonyl, the other one's placed on.
Okay. The attack on an alpha beta unsaturated carbonyl by Grignard is on the carbonyl.
Carbonyl. Okay.
The attack
On the
of a dialkyl
cuprate.
cuprate on an alpha beta carbonyl is on the
Beta.
beta carbon.
Oh, okay.
Okay.
Yep. Cool.
Let's skip that. Okay, you have never seen it, I don't have to show it to you. What do you have here? What do you have here? Diketone, yes?
Mhm.
It's two carbonyls. That makes that
Alpha.
pH 9. Okay? Oh, the pKa, very good for you. So, that means that I can pull this off with something that has a pKa of 16, easily. Okay, resonance stabilized, blah, blah, blah. This is a carbonyl here, this is a negatively charged after you pull the proton off.
Mhm.
And what is that going to look like? Like a
Nucleophile.
nucleophile, yes?
Yep.
And after that, instead of adding an alkyl halide, what do you add now? You add an alpha beta unsaturated. The attack will be on the beta carbon, yes? I was the only one on that. The only one on the carbonyl was that. I just showed you that, so if you get a Grignard. So the attack will be here, yes or no? So I am going to redraw this structure. Yes?
Mhm.
Attachment is going to be where?
Right there.
On
Right
this
there.
carbon, yes?
Yep.
I'm going to draw an attachment to a carbon. That carbon will be the beta carbon, yes? This carbon here.
Yeah.
What does that carbon have on it? It has,
That's
it
CH3.
does have a hydrogen, but it has
CH, carbon, CH3. Yeah.
CH3.
Uh-huh.
What else does it have on it? It has
CH.
that carbon
Uh-huh.
and a carbonyl. So this carbon is lost, the double bond is lost.
Yeah.
So this will be what?
CH2.
2.
Yeah.
And that will be still a carbonyl.
Carbonyl.
So CH2
Uh-huh.
and carbonyl. Find what the product of that would be.
I'm attacking the beta, right? So that's partially positive, that's partially negative, that's partially positive. So I'm gonna attack right there.
Okay, guys, what do we do here? Now, once again, you do not memorize what is happening, you understand what is happening. Because when I give it to you, it is going to be so mixed in the soup, you're not even gonna see the taste of it. Okay? What you have here is a what? This is alpha, beta,
so
unsaturated.
saturated, yeah.
I have here
The dialkyl cuprate, it's
the
gonna attack
addition will be where?
beta,
In the
beta
part.
position, yeah.
Very good. I redraw this business, and the addition will be here,
Mm-hmm.
CH3, and that's done. Okay? Unexpected, you've never seen this before. I have sodium methoxide to this. What do you get?
Extract the proton,
We
that's gonna be a
get
nuclear.
carbonyl from here,
Yeah,
that's
yeah.
right.
Uh-huh.
And then, what is it going to attack from there?
It's gonna attack, that's
It's
gonna
going
attack
to
the
attack
carbon,
the beta carbon.
yeah.
Beta carbon.
Mhm.
This is alpha beta unsaturated.
Oh, that's right.
It's
Yeah,
going
that's
to
gonna
attack the beta carbon.
That's
Now,
right.
what are you gonna get? And then,
You got
what is
it.
this step?
Decarboxylation.
So what you are going to get is this. That's first, not decarboxylate.
Okay,
Let's say we do this first,
uh-huh,
and then the addition will be here.
right. So you
So
got a CH3,
bond to the
yeah.
beta carbon. That beta
Uh-huh.
carbon has what in it?
a CH3,
CH3,
yeah,
that's that. And it has
a
CH2,
CH2,
CH2.
uh-huh.
Is that right?
Got a CH2. The double bond is, yeah. CH2.
Yes or no?
Yep, yeah, that's right.
Okay. That carbon is this carbon. It has a
Uh-huh.
CH3.
Uh-huh.
CH3 has CH2 carbonyl.
Mm-hmm.
CH2
Carbonyl.
carbonyl. And if I do decarboxylation of that, that goes away. And let's do a better structure, yes? 1, 2, 3, 4. 1, 2, 3, 4. Tell me if this is it. That is how many carbons that is? 1, 2, 3, 4, and 5. Whoops. Made a mistake, yes? 1, 2, 3, 4,
Make one more. Uh-huh.
and 5.
5, yeah.
What is it at the end of this one?
A hydrogen.
There was a methyl group where? Here is that carbonyl, 1, 2, yes?
Mm-hmm.
Methyl group on carbonyl, 1, 2, or you can say 1, 2, 3, yes? 1, 2, 3. Methyl group is there.
God.
And this came from the alpha beta, yes?
Uh-huh.
Alpha beta. This is alpha beta with a methyl group. Okay. Seems okay.
Yeah.
I don't know, what do you think?
Yeah. Nice.
Do those over there. You have 25 seconds. What do we get here, my friends, on the first one? What does that look like? It looks like alpha beta unsaturated, does it not?
Mm-hmm.
This is not a carbonyl though,
No.
right? It's not a carbonyl, but it is alpha beta unsaturated.
Yeah.
And you expect this to add to what side?
Beta.
To the beta position. How many of you put it on the beta position without ever seeing this before? If you saw it before, then you failed. How many of you put it here without knowing this reaction? Hello? And the rest of you have seen it? You saw it? Hello? Smack somebody. Okay, whatever, guys. Okay, it's a trick. Will this form a carboxylic acid from that?
Yes.
Yes.
Yes, right?
Will it form a carboxylic acid?
Yeah. Would it do that first?
We have to heat it or no? It doesn't matter, okay? Let's say that
There you go.
after
Thank you.
that, we are going to form this, yes?
Mm-hmm.
How about this one?
Pull that alpha proton, then that's gonna attack that.
Okay? Base,
Uh-huh.
once again, don't memorize the things, okay?
Yep.
Here is acidic,
Uh-huh.
and here is a base.
Base.
Pull that proton off, attack what carbon?
The
Beta.
beta.
So, what we are going to get is okay,
Connected to that.
that's it. The attachment into this one now.
Mhm.
What does it have? CH2 that. Yes or
CH2 and the carbonyl.
CH2,
Carbonyl.
carbonyl, and then
A ring.
this ring.
Mm-hmm.
You agree?
Yeah.
Guys, yes or no?
I have a question, why is it 2? I put 1, like 1 carbon on it.
Where?
When you, for the product. Like I'm missing an extra carbon.
Because this is a carbon, yes?
Uh-huh.
So, 1, 2, 3 carbons. You don't count this one because this one belongs to this one.
Oh,
Yeah, so you count, this is the first one you count. I'm missing one? Am I missing one?
Yeah.
You sure?
Yeah.
oh yeah.
Yes, you must.
Yeah, missing.
I did? How many carbons does that have?
Two.
The bottom one?
3. Yeah, you need one more.
Alright, let's do it again, okay?
Yeah.
So, here's that carbon, yes?
Uh-huh.
It will be attached to this carbon.
Yes.
That carbon is out.
Attachment. Okay.
Then it's gonna have
Another one.
CH2
Yeah.
and carbonyl, you agree?
Uh-huh.
So this carbon attached to this one, CH2, carbonyl.
CH2 right
CH2.
there. Yeah. Carbonyl.
This one is gonna have CH2 and then the carbonyl,
Uh-huh.
like this. Okay, let's count. 1, 2, 3, and 4. Let's see. 1, 2, 3, and 4. Yes or no?
Mm-hmm.
If we were to cut this, what would we form? We form the double bond here, yes? So that's correct. I made a mistake. Very good in catching it. Let's see if we can make another one. By the way, there are something called Michael donors and Michael acceptors. These are the possibilities you have. A Michael donor is one that will be the nucleophile, and the Michael acceptor will be the one that gets attacked. Most of the time, what is it going to be? Alpha, beta unsaturated. Yes? Hello?
Yes.
So, Michael donors are things like this.
Okay.
They are dicarbonyls, okay? The conjugate base of a ketone is not a good Michael donor, okay? What else can I have? What do these do? They attack what?
Electric arc.
They attack the alpha beta. Okay. Another one.
They attack the alpha beta. Kill.
This is kind of analogous to a ketone, yes? Yes?
Mm-hmm.
What else? And of course, dialkyl cuprate, which we have already seen. I have another one here. I'm not very fond of this one. But this is more than likely I won't give you this one. Michael.
Acceptors.
Let's say, whatever, that can be ketones. Make you sleep a little bit.
Oh man.
Take me home, you'll sleep every night when I teach you chemistry. Okay, guys. You like that?
Mm-hmm.
Once again, we already had an example of this, yes?
Yeah, just now.
We don't have to do an example of all of them. Okay? But I'm gonna try to stay away from this, okay, is what I'm telling you. I'm gonna try to stay away from that NO2 there.
Why don't you like it?
Huh?
Why don't you like it?
Why don't I like it?
Yeah.
No, it's not because it's messy, I just don't like when people say no. No. Girl's favorite word.
Oh man.
I don't like it for any particular reasons, we just don't do a lot of things with NO2, yes?
Mm-hmm.
So, I lost it. Now, here's a ketone, yes? This thing you see there is one of the microdonors we have done. Microdonors that we have done are, in general, diketones, yes?
Mm-hmm.
This is not stable enough, or this is not nucleophilic enough, okay? So we have to do something else. So let's say not stable, or not a good microdonor. As a result of that, in order to make a ketone a better microdonor, we have something called dork enamine. Yes? It's not called dork.
Stork.
I made a mistake again.
Dork.
What is it called?
Stork.
Oh, stork.
Dork.
Very good. Stork. Enamine. And of course, the stork enamine. Stork is the guy that did it. Hopefully he doesn't see the video. Because you guys are calling him dork. That's not nice. And enamine, what's an enamine?
It is a double bond. You replace the O with.
You guys forgot already what an enamine is?
It's a carbon double bonded to a.
No, just tell me what an enamine looks like.
It's
Like this, yes?
Yeah. No, that's oxide.
That's a hydrazone.
That's an oxime.
I mean,
That's not an enamine.
Yeah, that's an oxime.
So then the hydrazone is the
With the NH2.
NH2.
Yeah.
NH2 here.
That's a hydrazone.
No, that's a hydrazone.
No. No, because that'd be,
An enamine,
it can't
if
have.
you start tripping,
Two R groups with
mean,
it.
amine,
It's got two.
mean, amine.
Yeah.
Yes?
Yes.
Yes or no?
Mm-hmm.
So it has a double bond
With the
and it has an
nitrogen.
amine group, yes?
Yeah.
According to what you were telling me, you'll
Double,
have,
double bond. Not,
Double
yeah.
bond
With
somewhere.
two R groups.
and this has to be 2R groups.
Yeah.
Now it will not form the enamine, okay? So the secondary amine, it gives you the enamine. And of course, the resonance structure of the enamine is, let's say, that makes a double bond in there.
Mhm.
So let's say a silly resonance structure. Now this is positively charged, and what happens to this double bond? The double bond will go there, and that
Make
will
a new-
form
A nucleophile.
the nucleophile. This one is stable enough because of that nitrogen there. It's stable enough, it's strong enough to undergo some type of nucleophilic addition, yes?
Addition. Okay.
And that could take place in an alpha beta unsaturated. We will see. It undergoes nucleophilic attack on anything, yes?
Mhm.
You don't know, but if I give it to you, you're supposed to be able to tell. There it is.
Yeah. He does it on purpose. Poke you.
You gotta go to the bathroom again? Yeah. Your blood pressure went up that high, huh? At least I mean you're spreading that disease. Okay, so let's say I do this in step 1. And I add that in step 2. Provide the product. By the way, what's the product?
You're gonna have this. Redraw that with the.
Ketone
Uh-huh.
with secondary
Secondary
amine. What
amine.
is it going to give you? Enamine,
Enamine.
yes?
Yeah.
It's going to give you an enamine. And
With a
then the
positive.
enamine,
Yeah.
nucleophilic here
Uh-huh.
will attack what carbon?
Beta.
Beta carbon. Let's see if
Uh-huh.
we can draw that this time. Hopefully, the professor is not going to make another mistake, yes? Because if not, you catch it, yes? You catch it.
You gotta put that nitrogen.
So, this is the alpha carbon. I'm going to attach it to this beta carbon.
But that's wrong.
What's wrong?
Because you gotta have the nitrogen. Yeah.
Oh, yeah.
Yeah. with the, yeah, there you go.
Where's that positive charge?
Let's say. You guys wanna get technical?
No, that's just the right thing to do.
What do you want to have here?
Have a
Nitrogen single bonded or double bonded?
Double bonded.
Now you're missing a double bond somewhere.
I'm missing a double bond?
Yeah. You can't just have
Yeah,
some
because
double
it has to
and
be
double bond
resonance.
somewhere.
In
Okay,
order,
why don't you do each step, Do each step.
These you do it, done.
because if you do this,
Do these things on purpose.
I don't know what you guys are going to do when I'm not here and I die.
we're gonna die too.
We're gonna do it like that.
We'll meet in hell, okay? Okay, look, let's do this. In the third step, we're gonna do
Carboxylic
that.
acid. Because if you do this,
Now, we don't need heat. Everything doesn't need heat, my friend. Some things. Some things are hot from the beginning.
you're fucking clown, man. Listen. Look, this what I'm doing. This, boom, look, right? Got the two R groups. This gonna be positive. That's gonna make this negative, right? And then it's gonna have to attack this. If you got this with it. So this is alpha, beta, because this is positive. This is negative. This is positive. This is a negative. It's gonna attack this positive, right? And you're gonna get this.
I missed the Okay, I think I missed the
But then
I
the
think I
H3O
missed the
plus. H3O.
Fix it.
I think, but I don't know. What do you miss it? I missed the carbon.
I don't know.
How many carbons?
1, 2, 3, 4.
How am I supposed to know? Do I look like I know everything?
2, 3, 4.
So,
Hey, don't. You never know. Just
you think professors know everything, don't you?
put in the H3O plus.
You've never taken a class with a professor that doesn't know? Maybe this is the first one, huh? No. Okay, guys. Okay, I don't want to go into too many details of this, yes? You guys are stressing me with this. The amine and a ketone, yeah, let's say yes?
Uh-huh.
An amine and a ketone. I need a little bit of acid in there, yes or no? For this to occur, yes or no?
Yes.
Yeah, I need a little bit of acid in there, okay? I don't want to put it to start getting this a little upsetting. But let's say I have this amine, I have acid, and it's going to attack here, yes or no? And it's going to form, you're going to lose this oxygen as what? It's going to be lost as water.
Yeah.
Okay, that's what this
Okay,
this says here.
yeah.
And when it does get lost as water, what you are going to form this, which is not a good resonance structure, yes? Not a good resonance structure. The one that we have is this one, with the double bond here. Let's say that this double bond attacks. I don't want to draw the double bond here, because that already confused somebody. Let's say that this double bond is going to attack what? The alpha beta.
Later. Uh-huh.
Yes or no? It's going to attack the alpha beta. When it attacks the alpha beta, then this double bond will go in there and make another double bond here, and the new bond is gonna be on this side, yes or no?
Yeah.
So, let's say, this is what we have, which is what I wanted to get to, because you'll see what happens at the end.
Okay.
This is the carbon that is gonna be bonded to the beta carbon from the carbonyl. Yes?
Mm-hmm.
This is the beta carbon.
Mm-hmm.
That has a CH2, that, yes?
Yeah.
Is this the beta carbon?
That is. Yeah. There you go.
Like this?
That's the one.
You agree, yes or no?
That comes down.
Okay.
That.
You agree?
CH3.
This carbon is coming from this thing that I have here. Beta carbon, alpha carbon, carbonyl. I don't know how many other ways I'm gonna say it.
Yeah.
Hopefully something triggers. Now, when I have this already, that is not going to be the product. Is it going to be the product? That's not going to be the product. When I add this, what's gonna happen? There's not minus H2 anymore. This is going to go back to carbonyl, yes?
Carbonyl. Okay.
Which is what I wanted to draw from before, but you guys provoked this. So at the end of the day, like in the movie The Shooter, have you seen the movie The Shooter?
You seen that one?
You haven't seen that movie?
I haven't seen that one.
Yeah.
Oh, that's when he patched himself up.
sniper
Yeah, yeah, yeah. Oh,
and-
yeah, yeah. I saw that. Yeah, yeah. I saw that.
Danny Glover is always saying, I win, you lose. So the answer to a Stark enamine synthesis, does it have an enamine in it?
Yes.
The answer?
No. What?
answer.
Answer.
No,
No,
you don't
no.
know that this was ever an enamine, okay? The enamine is used to make this.
Make that.
And by the way, this is a what-to-what carbonyl. This is a 1, 2, 3, 4, 5. This is 1,5. Yes? And 1,3 is the other one. So whenever you see a functional group in the 1,5 position, that probably came from, oh man, I erased this. I'd say this is 2 and 3.
Okay.
Guys, the product quickly. I want the product, nothing else. Okay, ready? Is that the product?
No, because you got that
The
H3O
product
plus.
has nothing to do with
That's
the
the-
enamine, yes?
Right.
Yeah,
That
with the H3O plus, that means that the enamine is gone,
Yeah.
which is most of the time, the synthetic strategy. So, carbonyl still here. Now, the nucleophile was here on this tip, yes?
Mm-hmm.
Alpha carbon. I am going to make a bond to the beta, and then alpha, and then carbonyl. Yes or no? It is an aldehyde at the end, so I place an aldehyde. Is that enough carbons, or did I make a mistake?
No.
Now, I do them, yes? And you should do them too. And you just count the number of carbons, because it's possible.
Yeah, that's good.
You made a mistake. Yes, you gotta check. This is supposed to give a 1, 5, yes? 1, 2, 3, 4, 5. Okay, that seems to be okay. This was alpha beta. Here's the alpha, here's the beta. Must have been cut there. This bond is the one made between the electron pairs from here and this beta carbon. Yes? that good or no? You like the dork enemy?
Certainly do.
When do you use the dork enemy? The stork enemy. When do you use it?
When it's not stable.
When it's not stable,
Stable.
when it's a ketone, is when you use it, okay? If you have a dicarbonyl, would you use it? No, you don't need to use it for a dicarbonyl. My question is, how do you go from here to there?
1, 2, 3, 4, 5. Oh, stork. I mean, you have 1, 5. So
Why is
you-
there girls' hair inside of my camera, man? What are you doing? What happened?
It was her. That's why she left. No, just kidding.
Okay, what the deal is here? Hmm? Yeah, that's how we're gonna make it, but which one?
Yeah.
So, what do you see here? This is a ketone.
Ketone, yeah.
I cannot do a regular Michael addition, yes or no? You need to write it down. Oh, no regular Michael addition. So what do we have to do here?
Make it into a stork.
I have to
Stork?
make it a stork
Stork.
enemy. I need to know how many carbons away, yes? 1, 2, 3, 4, 5. This is a 1,5 dicarbonyl.
Right.
So what are we going to do?
You stork.
We are going to make this
This
one
one,
an
the
enemy.
enamine, yeah.
So you make it an enamine with
CH3,
a secondary,
nitrogen.
yes, secondary amine.
Uh-huh,
And we're gonna say minus H2O.
right.
So you know that the water is taken out, and minus H2O is because of what?
Because it leaves as water first,
So
right?
it doesn't go there.
Yeah, but why do we say minus H2O? It has a very specific meaning.
To drive the reaction.
To drive the reaction towards an enamine formation. Outstanding. So now here is H3O plus. Yes or no?
Mm-hmm.
Make water a better leaving group. In the second step, I am going to add,
You're gonna add that,
I'm going to add
alpha
the alpha
beta.
beta.
yeah?
Let's look here.
You're
I'm
gonna
going
cut
to
it.
add the alpha beta. This carbon belongs, this is carbon alpha, this carbon belongs to that one.
Uh-huh.
I'm going to cut it here, and I'm going to make it alpha beta here. So, it will be alpha beta, yes, alpha beta,
Uh-huh.
carbonyl, with this business on it. You agree?
Yes, sir.
Yeah,
You like that?
yeah.
If you're a chemistry major, and you take advanced organic, you're gonna have to. They're going to drill you again and again and again with this type of reaction. Hopefully you make me proud. Here is that. How do we go from that? So when you look at it, it's very scary, isn't it?
So you just take that reference it down, and then you just.
I don't know, it looks very scary to me.
It does. That's when you just.
First of all, in order for you to know if you can make this, you gotta check if it is a 1 to 5. Yes, 1 comma 5. Is
Yeah.
it?
Yes.
Yeah.
Okay, very good. So that must have come from,
A stork.
Stork.
well, yeah, but how do you know it comes from stork? It came from alpha beta addition, yes?
Mhm.
But how do you know it's stork? Because the starting material is a ketone,
Ketone.
not a dicarbonyl,
Carbonyl.
yes? So this is a ketone, That's torque in a mean. Where do I clip this? Where do I cut it?
Between the,
Here?
No.
no,
Why not?
Carbonyl.
alpha, beta, between the ring and the, and that,
Gouge.
between
Why
the
not?
alpha and the beta.
No? Why not? Because that's not where it goes, right?
It's gonna be in between the.
Yeah, but this is alpha beta, right? Is this not alpha beta?
Yeah, but the other side is also
Yeah,
alpha
but-
beta.
So which alpha beta do I choose?
Yeah.
Well, I choose this alpha beta
Uh-huh.
because this is the CH2, CH3 from before.
Right.
So that will stay there. You can't cut it. So I'm going to cut it here.
Mm-hmm.
Where is the beta, alpha beta unsaturated going to be?
There.
Right there, yeah,
Yes.
because
Yeah.
alpha,
So-
beta.
That came from, in the first step,
Enemy.
stork
Uh-huh.
H3O plus minus H2O. Second step,
Yeah.
is that okay? Yes or no?
I didn't see that. I didn't see
You don't
that.
like it like that?
See.
I didn't draw it in the same position, okay, so you don't get used to it. And then next step is, it would have the nitrogens there if I don't do this step, yes?
H3O plus.
So H3O plus will give you the dicarbonyl, okay?
Wait, so why didn't we H3O plus?
Because you need a little bit of acid, right?
We didn't do H3O plus? Of course we did. You don't see it? It's right there. We didn't do it because I forgot or I didn't notice, and you did the same.
No, I noticed, but that was wrong.
Oh, I told you that it was wrong?
I thought I was.
Oh, why do you think that? You tend to make mistakes all the time?
Yeah.
So do I. Hey guys, last problem. No, maybe not. Okay, what now?
1, 2, 3, 4, 5. Gotta look at this 1,5, which it is.
Okay, 1,5, yes?
Mm-hmm.
1, 2, 3, 4, 5. That must have come from alpha beta unsaturated. You notice this is
A
ketone
ketone.
or aldehyde.
Uh-huh.
It's not going to work in a regular Michael addition. So what are we going to do? Stork.
Uh-huh.
Keep doing this in the front and the back. It's just minus H2O
H3O plus.
and H3O plus. That is going to give me the enamine.
Enamine.
Yes? And in the second step, what do we have? We have to add the alpha beta. Where's the alpha beta at? Here's the alpha carbon.
Uh-huh.
The beta's right in
Beta.
Here's the
Right.
beta, which is also beta to that. So I'm going to cover this and I'm going to make alpha beta unsaturated there.
Mhm.
So alpha beta unsaturated. You agree?
Yup. And H3O plus.
And in the third step, H3O plus to
To bring back, keep the aldehyde back. Keep
Schwab. Huh? What you say?
Why is the CH2 from the top, from the other?
You mean, this is
Yes.
a CH2
Yes, where is it?
and this is CH3. That's a CH 2, not anymore 2, right? Because one proton was pulled off. And this is a CH3. Guys, bring that IR and NMR next class, okay? Unfortunately, it's gonna be too late for you guys, right? Guys, you ready?
Yeah.
What does this give you?
That attached with where that CH3 is?
Carbonyl,
Yeah.
pull this alpha proton from here.
Yeah. That become the nucleophile.
And that became the nucleophile which attacked
Attacks
the
that beta.
beta carbon.
Yeah.
Okay? It attacked the beta carbon and it formed
Bam.
that,
Bam.
that,
With the carbonyl.
that.
Yeah.
Check if that's okay.
Okay, you got bam.
Yeah.
Uh-huh.
Okay.
Bam. Uh-huh. Bam. Uh-huh. Bam, bam, bam. Yeah.
Because the end of the CH3 is not acidic. It is only acidic the alpha proton.
Right, but the base protonates, right? Takes away an H.
Yeah.
Why does it choose?
It chooses it because it's acidic. This proton here is acidic, my friends. This is the alpha proton. This is beta. That's not acidic at all.
Yeah.
Over its dead body, is it going to lose that? Or this one? It's not gonna happen. So, what'd that be? Look.
Would that be?
So let's say I treat this with sodium hydroxide now. I treat
Yeah.
it with a base. And what's gonna happen is, it's gonna pull a proton off from somewhere. Now here's what's gonna happen. It's gonna pull off this proton. Because it could pull off this one, it could pull off that one, that will not give you something that is useful. It's gonna pull this one off. And when it pulls this one off, there is a carbonyl that is
Oh,
in
okay.
very close proximity.
Okay.
And when it attacks that carbonyl, what do you get?
Cyclic?
You get like a cyclic compound.
Yeah.
And if
But that
you
O-
with an OH, yes,
yeah.
with an OH there.
Uh-huh.
And if you lose that OH, what do you get from that? Alpha beta unsaturated. Alpha beta unsaturated to which one? Alpha beta unsaturated to this one here. Yes?
Mm-hmm.
Yes or no? Try to draw that.
All right.
So, let's say I do here sodium hydroxide and heat, yes? When we had an aldol condensation, what did we need to do to heat, okay? It can be done in basic conditions or acidic conditions. H3O plus and heat is the same, right? Okay, you drew it? First things first, yes? The ring will be how many members?
5.
Five.
6,
No. 1, 2, 3, 4, 5.
Okay, this negative charge here, yes?
uh-huh,
Attack there.
yeah,
So, this is part of the ring. Is this oxygen part of the ring?
no,
No. This carbon is part of the ring. That carbon is part of the ring. So I start counting from one side all the way to the next. 1, 2, 3, 4, 5, 6. That is a 6-member ring. I am going to draw a 6-member ring that is already there. And then I am going to, very pretty, write another 6-member ring. Yes or no? Here is where the OH should be at, yes? And here is the carbonyl. You agree?
mm-hmm,
Wait, I don't understand. Which attacks which?
What?
Who attacks who?
What do you mean, who attacks who? Guys attack girls.
Yeah, but how did the ring close in?
Well, the sodium hydroxide will make that, yes? And this will attack that carbonyl. Electrons go that way. That
Mhm.
negative charge picks up a proton from water, becoming that alcohol.
mm-hmm.
Yes?
But doesn't it drop the OH leaves
Yeah. But we are here in this step first, okay? Just so you can see it.
Why wouldn't it attack that other carbonyl?
Which one?
The one next to it?
This one?
No, the one next to the lone pairs.
That's fine. Yeah, how?
Why wouldn't this attack this one?
Yeah. Yeah, they're too close.
I mean, not that they're too close. They are the same.
Oh, okay.
It's like that. That is like that, yes? Resonance structure. Yes, they are the same. I mean, you could say, why doesn't it attack this one?
Because of proximity?
It is the same as it attacks this one. If it's 6 carbon, it's 6 carbon. You can have a question in why doesn't this one attack that one? This one doesn't attack that one. And it doesn't attack it because you need to form a 5 or 6 member ring, okay?
Is it more stable?
Yeah. 5 is faster, 6 is more stable. Okay, guys, what are we gonna get from here?
A double bond.
Now, when I heat this, this will leave, and I am going to have a, you don't erase it, right? You leave it. I'm erasing it because it's easy for me. There you go. Is that alpha beta?
Mm-hmm.
Yeah. Yeah. Oh, and I have the CH3 here, yes?
Mm-hmm.
Nobody noticed? That's what you were gonna ask?
Yeah, something else.
The name of this is called the Robinson annulation. Robinson. Robin, does Robin have an S? Robinson annulation. And in this Robinson annulation, what we get is that type of ring, okay? And you have to have the carbonyl. Let's see. So, this first step, what's the name of this reaction up to here? Name of this reaction? Michael
Michael
addition,
addition,
yes?
yeah.
This is Michael addition. And what's the name of this reaction up to here?
Robinson annulation?
No, no.
No?
Robinson annulation is
Oh, it's
everything.
alpha beta, right?
Robinson annulation is everything. But this first step is a
It's
Michael
Michael
addition.
addition, yeah.
And the second step is what?
Alpha beta, unsaturated.
It has a
Alpha
name.
beta.
What is it called?
Condensation?
Aldol condensation.
Oh,
Yes? So the first step is Michael. Right? From here to here is Michael addition. And from here to here, that's called an aldol condensation, in which a carbonyl or a carboanion from a ketone will attack another carbonyl. And then it will form an aldol, which was what it was. And then with heat, you get an alpha beta unsaturated. Did you write it down? Micro addition and aldol condensation, second part.
And altogether, Robinson.
And altogether is called
Robinson.
Robinson annihilation. I am going to send you these 2 pages. You print them. I'm going to send them to you PDF when I get to my office right now. I'm going to send them to you. What time is the class over? 30?
Yeah.
So it's done already, yes?